So basically, the first topic for the year is exponents and surds. And I just want to start today with a little bit of a check of what you guys know already. So we're going to do some multiple choice questions. And I want to know from you in the chat, which of the following is a power of 5? And you can vote in the chat with A, B, C, or D. So let me see those votes coming in.
Pop those answers in the chat, guys.
What do we got going on here?
D is very popular.
D is very popular. I think I know why. Okay. Which of the following is a power of 5? So if we look at this, if you know, 5 times 5 is just 25, right? And if you take 25 and you times that by 5, what do you get? You get 125. And so the correct answer is D. Okay, so didn't see too many problems there, but it's just important. Another way of writing 125 is also just 5 to the power of 3. And so this is one of the main things about exponents, is that they often allow us to write quite big numbers in shorter ways. It's a lot quicker to write, and especially when you get to like even bigger numbers. A lot of what exponents and exponential notation does is make big multiplications or long multiplications much easier to write down. Okay, you weren't too bad on that one. Let's see how you do on this one. So I want to know, what is the correct answer for this one?
Keep those answers coming, guys.
So in the chat, I feel like the engines are, we started this lesson with the engines running. I see lots of A's, and the law that I was looking for, we often call it law 1 or the additive law, is if you have two numbers that are the same base, you can simply add the powers. And so in this case, the base is 3, and what do you get if you add 4 and 3? You get 3 to the 7. So the correct answer is A.
Good job, guys.
If I'm going too fast or unsure, let me know. But really, this is the first important law from exponents. You have to know it. I'm sure many of you do, but just to make sure you know how it works. And let's go on to the second question then. Well, sorry, the third question. See if you get the answer to this one. So 2 to the power of 10 divided by 2 to the power of 5. What do we think the correct answer is? Is it A? Is it B? Is it C? Is it D? And I'm looking at the answers, and I see Fila, Nondamiso, Jabu, Kia. There's a lot of B's in the house. And again, I'm pretty sure I know why, because in this case, I'm dividing two numbers with the same base. So I write down the base, and then all I need to do is subtract the powers. And so the correct answer is B. Okay, so this is what we call law 2. Bases are the same, and we're dividing, we subtract the powers. Any questions or comments? Anybody want to clarify anything? Let me know in the chat or raise your hand. Otherwise, we're going to move on. Think of this as the sort of stretch. We're doing the stretch at the beginning of the lesson.
Okay. Warm up.
Stretch it out. Let's do this. What about question 3? What do you think the answer to this question is?
You guys are quick.
Fastest finger first. I think everyone's been on their phones a lot.
Yes.
Well trained. This is a little bit different to the last ones because I only see one base, but I see a power and then another power. Now, I see the answers in the chat. People are pretty convinced that their answer is correct. Could somebody maybe explain, maybe somebody could put their hand up and explain to me how they got their answer? I'd love to hear your thinking. I'd love to get a sense of how you thought through the problem. Who's willing to just pop their hand up and then I'll unmute you and just, you don't even have to be right. I just want to hear your thinking when you see this question. Yeah, let's go to Fila. Fila, what were you thinking when you did this question?
So since they have a 3 outside, I'm thinking that you multiply everything inside the bracket. So therefore, I calculated I said 5 to the power 4 multiplied by 3, and also 4 multiplied by 3, and also 5 to the power 3. I don't know if you get what I'm saying. So I multiplied everything inside the bracket.
Yeah.
Inside the bracket. So I got 125 to the power 12.
Yeah. So what we do is we say we're raising the stuff inside the bracket to the power of 3. And the law says that you basically take the power that's inside and you just multiply it by the power that is outside. So you're not multiplying it by 3, but you're multiplying the power by 3, if that kind of makes sense.
Okay.
And so you get 5 to the 12. But just in case you want to know why this makes sense, if you imagine something to the power of 3, what that means is it means multiply whatever is inside the bracket 3 times. Okay, so say, for example, another way of writing this question would be 5 to the 4 times 5 to the 4 times 5 to the 4. That means exactly the same as this one. But it's easier to see in this scenario why the answer is 5 to the 12, because the bases are all the same. So we write down the base. And then what do we do if the bases are the same? We add the powers. So that's 4 plus 4 plus 4. And so I wouldn't do it like normally. I'm just showing you, though, why the answer is 5 to the 12. Now, law 3 says that when the base is there and you've got powers next to each other, you can just multiply them. And so you get the same answer. So I hope that is helpful in showing you the law is true and also why it's true. Give me a little thumbs up if you feel like you understand law 3. I call this the power law because it's power to the power. Okay. Are there any questions about that before I move on? The wonderful thing about being live is if there are questions, just pop it in the chat or raise your hand. Otherwise, I'm going to move on. Cool. Nice little sneaky one. Well, not sneaky one, really. Let's see if you can do this one. What's 7 to the power of 0? All right. So if I look at the chat, Isa says it's a B. Amor says it's a B. Letabo says it's a B. Yeah, lots of B's in the house. And you're quite correct. Anything to the power of 0 is going to be 1. And so B is the correct answer. Okay. Another important idea in this topic is that anything to the power of 0 is 1. You'll see this idea come up. And then there are these 3 laws which we've just kind of done examples of. Now, I'm pretty impressed by what I've seen so far. I feel like you've understood this. And so I'm going to move on to some harder questions. I do feel like you understand the laws. And so I'm going to go on to this question. So take a bit of time, and I want you to think about what do you think the problem is with this question? And I want you to put in the chat what you think the problem is. And then once we've decided what the problem is, if we can get an answer to it. And I'm going to give you a bit more time here because this is a harder question. Okay, off you go. And I'll watch the chat for a bit.
Let us know what you think in the chat, guys. What do we
What makes
do?
this question difficult or irritating? Nelisa, I think you are onto something.
Melissa.
Tando, you are bringing some good information there. I like it.
Great hints, guys.
Now, if I think back to grade 10, there are always some techniques that are, my brain is going, I've seen something like this before. What do we do with the 20 normally? So normally we would break it down, wouldn't we? Now, there's actually two ways you could do this question, but I was thinking, couldn't we just write 20 as 4 times 5, right? So 20 is 4 times 5, because then at least we have a 4 on the top to play with the 4 on the bottom. Now, you could break the 20 down into what's called its prime factors. You could also break the 4 down, but in this situation, I don't think it's, but I'll give you that hint. So now, knowing that you know that, which of these 4 do you think it is? Maybe lock in your answer, see what you think it is, and we'll go from there. And you can be wrong, that's not a problem. The act of even voting and then seeing what comes afterwards will help you more than if you stay on the sidelines. Okay, so
even if it's just the guess, it's okay.
It's okay. More than okay, you're moving forward.
Yes.
So people are saying A. I'm afraid I think I disagree, but let's go on a bit of a journey. So I'm going to replace the 20 with 4 times 5, and I'm going to write it over that. And then I'm going to write it like this. Now, often in exponents, when I see division, I like to write it like this because it's more visual. It shows me the relationship. Now, I also know from a previous law, because there's ones here, I think I can write this as 4 to the 6 times 5 to the 6, like this. Can you give me a thumbs up if you understand the steps I've gone through when I've gone 4 times 5 is 20, and then I've applied the 6s to here? Give me a thumbs up if you understand how I got to this step. Now, I don't see this as any of the answers yet, but maybe there's some more to go in my journey. Okay. What do you think the next step is here? Anybody want to come online and just give me a little audible hint? I'd love to hear your voices. Who thinks they know what the next step is?
Promise we're nice, guys. Don't be shy.
Let's go to Tebogo. Tebogo, what do you think? What's the next step?
I think you're gonna cancel the 4. How many times does 3 goes into 4? And then it's gonna be 4 squared times 5 to the power 6.
You are so close. So I love what you were saying about the 4s interacting. So the 4 over here divided by the 4, but there's a law that we bring into it. What law are we going to use for this? What do we need to do? What do you think?
It's powers of the same base. When you're dividing them, you subtract the exponents. So it's going to be 6
Exactly.
minus.
Perfect. And you get this. So you get 4 to the 3, and then the 5 to the 6, unfortunately, there's no one to play with, right? So essentially that stays the same. Now, if I look at this, it's definitely not that. It's definitely not that because it's bigger than that. And it actually can't be this one. So this was a bit of a sneaky one. It actually is none of them. This isn't a typical exam question. I just wanted to show you the thinking, to show you how exponents can be a little bit sneaky sometimes. And you have to really keep in mind the laws. as you do these. So that was designed to kind of make you think, and clearly it did. Okay, are there any questions before I move on? Don't worry if you felt that was a bit weird. It was deliberately so. Okay, how about, let's do this one. Let's do this one. What do we think the answer to this question is? And you guys are like, come on, give me something a bit more exciting. So you're quite correct. A is the correct answer. It's law 1, right? Bases are the same, add the powers. I thought some of you might be taken by this one, but you're just too clever for that. So well done.
Yeah, it takes a lot to catch them out.
But the 2 and 3, it makes you, some people think, oh, what about law 3? And they start, but it's important. There are 2 bases that are the same. There you add the powers. Okay. A little bit harder, this one. We haven't actually spoken about this yet, but I want to see how you do on this. This is kind of an application of, well, I want to see what you get first. I want to see you choose an option that you think looks the best, and then I'll talk about it. So you're multiplying 2 numbers. Which of these 4 do you think is going to be correct? Oh, I love it. I see some variation in the house. I see some A's, I see some T's, I see some D's, which means learning is about to happen.
A little debate.
Yeah, it's funny how, it's always interesting if there's a bit of a mixture, a bit of
Yes.
it means that we're onto something.
Definitely.
Okay, now there's a good amount of debate happening in the chat. I want to know, which of the 3 laws do you think is involved here? So tell me, do you think, or maybe you can even come online, I mean, you can put your hand up and tell me audibly, which of the 3 laws do you think is going to be involved here?
Anybody?
Is it law 1? Don't feel like it's law 1. Doesn't feel like it's law 2. But how can it be law 3?
Ooh.
Who wants to explain their thinking? And again, whether it's wrong or right, it's equally valuable at this stage. I just want to know what your thinking is. C'est beaucoup clair. Let's go to you. What do you think?
I think
Hello.
that hi.
Hey.
I think that it's law 3, but I'm not sure. I
agree with you. It is. Would it help you if I do this? Okay, so pretend if I had to ask you to sort of expand that, can you see how that would be 2 to the m times 3 to the m? Give me a thumbs up if you understand this bit. Kind of like, this is law 3 because you're applying the thing outside, inside. But now that might give you a little bit of a hint as to what the correct answer is going to be. What do you think the correct answer is here in this situation? So where have I gone? Did I just move up by mistake? What happened? Oh, there it is. Which of the 4 options do you think is correct here?
A, B, C, or D.
I'll give you a hint. I'll highlight this bit here. Okay. So what you need to see is that when the exponents are the same, what you can actually do is you can move that m outside the bracket. It's almost like law 3 in reverse. So this is like law 3 in reverse. You can take the power outside the bracket, and then it allows you to give some quality attention to what's in the bracket. And so 2 times 3 is 6, and then 6 to the m. So the correct answer is going to be 6 to the m. Okay, so that's really understanding law 3 well, because you're going backwards with it, but it still works. When something is equal, the left equals the right equals the left. It's perfectly fine.
Well
Okay.
done, everyone.
Now, I think we've been going for a while, and it is time for us to give our bodies a break. And so what I want is I want you to join me in standing up, and I want you to turn your cameras on. I'm going to stand up. I am too. And you are going to join me in a stretch. And Levo, if you could just give the shout out to the people in the room. Oh,
Please join us in the stretch, guys. Give your mind a break. Turn on your cameras. Let's see your lovely faces.
Yes. Let's roll the shoulders. Roll those shoulders, roll them back.
Promise your body will thank you after this.
Punched forward. Oh, so nice. Roll them back and then roll them forward. Yo, I really need to do this more often than just during my normal day. And then do a nice tricep stretch. There you go.
Don't be shy, guys. We're all in it together.
Switch it over. Oh, that feels fantastic. It may not look like it feels fantastic, but it does.
Even if your camera's off.
Yeah, just stretch it out, and then just let's do this one. I don't even know what it's called. Like that.
Arm hug or something.
This one. We have to look up what this is called, but it is good. And then just shake it out. Shake it out. There we go. I'm not very good at shaking.
I'm sure you guys are feeling like you can take on the world now.
There we go. Okay, so we know maths is quite demanding of our brains sometimes, and so we need to give ourselves a break. And one of the ways we can do that is using our body, right? Just to relax. Maybe we can do some deep breaths at some point as well. But exercise is a great way to do that. So what we're going to do next is we're going to do a little brain break challenge. And so I am going to give you this puzzle, and you need to figure out for me calm down, mouse, what the red sweet plus the purple sweet plus times the blue sweet is equal to. And I will leave it to you guys to figure that out, or give some hints and suggestions in the chat.
Who will be first?
Indeed. Oh. Oh, wait, I think I've broken something. Okay. Can you all see the screen?
Yes, we can see it, Mr. S.
Cool. So what options do we have coming through here? So I think a cool thing initially is to recognize that this is 3, because that's the only way we're going to get to 27. That is the same as 3 cubed. So that's my hint. And then if someone feels like they know what the answer is, just let us put your answer in the chat. Or you can also raise your hand and we'd love to hear from you. Oh, and let me put my monitor, my camera back. Okay. Some answers are starting to come through. The one thing I would say is that this is 3 and this is 3. And so together this would give you 6. So just watch out for that. This is going to be 3 by itself, but there are 2 blue sweets here. And so it might affect your calculation. I see Amor has an answer that's coming through. Justina. Again, there's nice variation in those answers. So that means lots of learning is going to come our way soon here. What is the next equation I would deal with? I think this one is taken care of. I think the next place I would go would be here. And I think that this would be 1, and that would be 1 because 6 times 2 gives me 12, which means this is 1 and this is 1. Now, the big question is, what is a purple sweet worth? What is a purple sweet worth? Anyone want to? Oh, Sandile. Sandile, I think I agree with you. Something times 1 is 16. That something has to be a 4. Which means that has to be a 4. Now, there's still some work to be done because in mathematics, we have to decide if addition gets done first or if multiplication gets done first. So which of those two is going to be?
If you would like to reconsider and change your answer, now is the time.
Oh, now it's, if you want the glory, I'm going to put it down there now. Sinako, Nondomiso, Nyasha. Okay, so the key idea here is to realize that BODMAS or PEMDAS says multiplication gets done first. And so you get 1 plus 12, which is 13. And so the correct answer is 13. Well done, Fila. I see you also got 13. Futsilo. Okay. All right. So we will do lots of puzzles like this going forward. Actually, this is a sneaky simultaneous equation, actually. We don't call it that. But we're sneaking in maths throughout the lesson. And yeah, just let us know, how did you find the brain break and the stretch? Did you enjoy it? Give us a thumbs up. If you were like, didn't enjoy that, give us a thumbs down in the chat. We value your communication. We do, guys and girls. Awesome. Okay, well, I think now we're ready for the last bit of the lesson. So let's get back to what we were doing. I'm going to give you 5 questions. In fact, let's do the first 3 first, and then we'll do the next 2 after that. So here are 3 questions, and I want you to figure out how do you simplify them without a calculator. And then once you've got your...
Listen, guys, let's do this. Sorry, mistakes.
Love the energy, love the enthusiasm. You're carrying us up the mountain level. Thank you. So once you've done your question, just pop your answer in the chat. And again, it's not so much about whether you're wrong or right. It's about seeing the debate because we can't shout over each other. It's nice to see us thinking about this together in the chat. I'll give you a bit of time. And yeah, while you're working, if someone has a question, now is a great time to raise your hand and ask it, because obviously most people are just working on these 3 problems. Okay, I like what I'm seeing, Yenzi. I like what I'm seeing, Nelisa, Kaklejo, Fila. Yeah, I think most of us are feeling pretty confident about number 1. It's just y to the 4.
Looking good, guys.
And for number 2, it's going to be 9 to the power of 2. 3 is a bit more interesting. Another question to ask is, which of the laws are you using here? So there's a power, and there's powers inside and outside. I think something like that would be useful. But I want to see it in the chat first.
You guys are doing great.
Can you still see the screen, Mabel?
Yes, we can still see it, Mr. Ace.
Yeah. I'm just creating something while we do this. Oh, wait. Okay, so with this one, it's the third law, and I think the answer is going to be y to the power of 7 times by x to the power of 14. And that's because the 7 gets applied to the 1 or multiplied, so it's 7, y to the power of 7, and then it's x to the 14. Are there any questions or comments or anything that we would like to clarify? Can't see the number clearly. Let's just see if this is, if I zoom in, if that's a bit easier. Okay, so I'm not seeing any problems with that one, so I'm going to give you the next 2. If there are any problems, let me know. I want you to try and solve number 4 and number 5 now. I want you to try and simplify. And there's some stuff in question 4 and 5 that I haven't spoken about too much yet, but we'll talk about it. I want to see if you remember this from grade 10 first, and then I'll talk through it. But in the chat, what's different about number 4? I want to know what's different too. I want you to call it out. What is different about 4 specifically that we haven't done here before yet? We have done it in grade 10. Tebogo, yeah.
Number 4 has a negative exponent.
Exactly. Can you remember anything else about negative exponents that might be helpful later in the lesson? Anything you remember from last year?
I think it's if, for example, it's 2 to the negative 1, it's going to be 1 over 2. So that the exponent,
Yes. So there's this thing.
The negative exponent becomes positive on the denominator.
Yeah, so if you move them above and below the line, they seem to go negatives to positives. We'll talk more about that, but that's exactly it. That is a helpful tip. Thank you. It's how we deal with negative exponents, and we can move between positive and negative as long as we follow the rule clearly. I'll talk about that now when we do the question, but that's a great tip. Thank you. Yenzi has said, yep, negative exponents. Letabo said, another way of writing a fraction. Yes, you guys have seen some of this before. It's good. The cobwebs are going away from grade 10. Let's see if we can get the answers for these. There's a couple of different ways we can do it.
You can do this, guys. Pop those answers in the chat as soon as you have them.
I was thinking working from, you could work from the outside in, or you could work from the inside out. There's a great debate about this, but I think I would make the inside simpler if I could. And so what I'm going to do here, not to say it's completely the only way of doing it, but 2/8 is the same as 1/4. And so that's one way of kind of getting some, simplification going on, is the one thing we could do. And then this negative on the bottom, we haven't spoken about this too much, but if we take a negative exponent from below the line and we bring it above, it actually does change to positive. And so that I probably need to talk about a bit more, but I could rewrite this question as x to the 3 times y to the 4 over 4. And then this would be to the power of -3 on the outside. Now, just to follow what I did there, 2/8 is the same as 1/4. So there's actually still a 1 here. And then I just moved the y to the -4 to the top. The -3 is still there on the outside. Now think about what else can still be done from there. And then I see one answer has come through so far. What else can we do? So at this point, I'm guessing the -3 needs to come inside. So what do I need to do? I need to apply it not just to here and not just to there, but also to the one down there. Okay, so I'm going to give you some more time because this takes a bit of, would you go from there? Sorry for my wonky handwriting. My pen stopped working, so I'm using my mouse. But see if you can see with how I got that bit. So what do I got? I've got x. Now, when we deal with exponential expressions, we normally like to have our exponents being positive. And so what I'm going to do is, at the moment, this x at the top and the y at the top have negative powers. If I move them below the line, they will become positive powers. And so I'll get x to the 9 over y to the 12. So give me a thumbs up if you understand how I went from here to here. Okay, so often with exponents, we want to have a positive power, so we're good there. Now, I would like someone to tell me, what am I going to do about this 4 to the -3? Who wants to tell me on audio or in the chat? I want to know.
Anyone who would like to give us a hint?
Who thinks they may have something for us?
Kando says floated. Not too sure
Floated.
what that
Okay,
means.
so I think what it means is move it to the top, and it's going to become 4 to the power of 3. And that would be our final answer. Sometimes teachers like you to leave numbers in normal form. So 4 times 4 times 4 is 64. But to be honest, I'm not sure if that's any simpler than what we had to start with. Both in my book would be seen as correct, but that is how we would do that one. Okay, so what we've incorporated in the fourth question is this idea of if we have negative exponents, if we move them above or below the line, they will change from negative to positive. I'll talk maybe a bit more about why that is in the next lesson, but for now, it's just good to know it. Okay. Now, I want everyone to try and do number 5 now, but if there are questions that are left over from number 4 and you'd like to ask, now is a great time to ask that. Okay. But for the rest of us, let's try and do number 5 or ask questions about number 4.
Keep going, guys. You've got this.
Yeah, I see answers coming through. Oh, sorry, guys. So how are we going to do number 5? The only thing I think is going to catch people is this -3 here. Because the -3 here is also being squared, not just the 3. That's what I want you to watch out for. If you square this, basically, I could write this out in 2 ways. Let me write it out the long way just to make sure you're clear on this. So -3a squared is the same as that. And then the one on the end here, the 2a cubed, that's a bit easier to see what goes on. You get 2 to the 3 times a to the power of 3. Let me zoom in a bit so you can just focus on this question. So what I've done to try and make this, to watch out for this bit that I know is going to catch a lot of you, is I've taken what's in here and I've simply written it twice because there's a squared outside. And that's a different way of handling it, but I know it will catch a lot of you that when you apply the 2. Then this next bit is just basically applying this normally like this. Now, if I want to multiply this all along, I look for how many a. So a to the power of 2, a to the power of 2, a to the power of 3. So I'm going to have a to the 7 in the end. And then for the numbers, I actually could just have one big number in front. So -3 times -3 is +9, because there's 2 negatives. And 9 times 2 to the 3, well, 2 to the 3 is actually 8. Right? So 2 to the 3 is 8. And if 2 to the 3 is 8, well, then 9 times 8 is just going to be 72, a to the power of 7. So think about how I did that. Now, the reason I did it, the yellow bit like that, is I knew that when you applied this 2, a lot of you wouldn't realize that it's actually -3 to the power of 2 that you should get. Okay? Now, if you'd done that, you would have got the right answer, but it would have caught out a lot of you. So anyway, let me see how you are feeling. What is the feeling in the chat? Do you understand? Give me a thumbs up. Even if you got it wrong, give me a thumbs up if you understand my thinking and my method. Okay. Can I please explain again? Okay. If we look at this question, I have to simplify the question. Okay, and there's different parts to it. The first part is this power of 2 that has to go on, and this power of 2 has to be applied into the bracket. But one of the challenges is there's a negative inside the bracket. And so for a lot of students, what they will tend to get wrong is they won't realize that when I apply that 2 from outside, I'm basically getting this situation happening. And then, so that's what's a bit tricky. Then the other bit, 2a to the power of 3, most students will see that the 3 comes out like this. And then we apply that like that. Now, if you follow the thinking here, this a over here becomes a to the 4. And so you can see how I get my a to the 7. So basically I'm going to get, let's do this. I get 9, then I get a to the 4, then I get 8, and then I get a to the 3. Sorry, a to the 3. A to the 3. And so 8 times 9 is 72. And if the bases are the same, and they are here, there's an a here and an a here, then I'm going to get a to the 7. So I get the same answer as down here. However, if you want to, instead of using law 3, if you just want to write this out twice, that also will give you the same answer in the end. And so just to show you, there is flexible ways of doing that. Okay. The important part is it's positive 72. So positive 72, because negative 3 times negative 3 is actually positive 9. And so that will catch you out as well. So Buchle, the most important thing I want you guys to see is negative 3 times negative 3 is positive 9. And because positive 9 times 8 still has to be positive, the final question will be positive. So that's the key step. Okay. Now, if I do it like what, Atakile? Okay. So we'll do more questions like this in the next lesson, but I just want to, when you have a negative number that's squared, so in this situation, when you have a negative number that's being squared from outside, it's always going to end up being a positive number because a negative times a negative is a positive. And so that's what I want you to watch out. We're going to see this come up again later in the section. But if we raise something to an even power, it always ends up being positive. Okay. Ladies and gents, I'm going to bring this lesson to a close fairly shortly. Are there any final questions that you would like to ask? It's been great being with you today. You've done really well. And we're about to do a poll, but are there any final questions? Well, in that case, I just want to ask you to help us by giving us some feedback about today. And so I want to know from you, if you could just give us some feedback about how you found the pace of the lesson, that would be awesome. And then it helps us kind of judge for the group what the group wants generally going forward.
We really appreciate your feedback, guys, so that we can be better for you.
Yeah, because one of the challenges as a teacher is that you don't observe body language in the same way you would in a physical class. But one of the strengths of online is it's much easier to get feedback if people feel comfortable. And so, yeah. Lebo, if you could just take a screenshot of that just so we have a record. And then, yeah, are there any final questions? Otherwise, for me, it's been a lot of fun. I hope you've enjoyed the lesson. And yeah, Buchle, let's go to you. What's your question? Let's unmute Buchle. Can you hear me, Buchle?
Yeah.
Hey.
I would like to ask if we can rewatch the lesson because I was pretty late today.
Okay, so here's the good news. On the Watobe website, all of our lessons, the recordings will appear within an hour, also within a day. So by tomorrow, or 24 hours, I think it is, hey, Lebo. So this lesson will be recorded and you can jump around the lesson and catch up all the bits that you may have missed. So that's just to go to the Watobe website.
Or the app, Mr. East.
Or the app. Or is it on the app? Sorry. Okay.